Waves. What are waves? Waves are a disturbance which transmits energy through matter or space. You can think of waves like signals in that they are carrying something away so that it can reach somewhere else. Energy travels away from its source in the form of waves. You probably have seen this before when a pebble drops into a lake or into a body of water, how it spreads afterwards, that ripple effect. And that's exactly what you should think of when you think of waves, how that message or that energy moves out and away. How does the energy in a wave move? Well, some waves require a medium to transfer energy. A medium is a substance or a material which carries a wave. So a medium can be water, if the subject is in water, but a medium is also air because air is composed of many different small particles that we can't see. So these are both mediums that waves might need to travel through to be able to transfer energy. We also measure a wave's frequency. A frequency is the number of waves or vibrations per second. And this will tell us just how many waves are passing through a given point in a set amount of time. So you can see the top wave here is a high frequency wave, and it just tells us that the wave is passing by a lot more quicker there. And then the other one is a low frequency wave, and we can see very clearly that there are less waves going through at the bottom. We also can describe waves by being able to identify the crest and the trough. The crest is the highest point of our wave, and the trough is the lowest point of the wave. Aside from knowing the different basic parts of a wave, we also need to be able to classify them in two different ways. The first way that we can classify waves is by their ability to transfer energy through a vacuum. A vacuum is an area in which there is no matter. Waves that require a medium require matter or a substance to travel through, and these are called mechanical waves. Waves that do not require a medium and can travel in a vacuum are called electromagnetic waves. And that's the basic difference between our mechanical waves and our electromagnetic waves. Mechanical waves require a medium. Electromagnetic waves do not and can travel in a vacuum. The next way that we can classify waves is based on the direction of the movement of the particles within the wave. So the first one that we'll talk about are the longitudinal waves. In a longitudinal wave, the particles of the medium vibrate back and forth, or left to right, along the same path that the wave is traveling through. These waves are sound waves, pressure waves, and seismic P waves. Longitudinal waves have areas of rarefaction where the particles are spread far apart, and areas of compression where the particles are more closely together. You can see that here in these two pictures, that area where the coil seems more spread out are the area of rarefaction. And then the areas where you can see that the coils or the particles are bunched very, very closely together, those are the areas of compression. The second way to classify waves, if we're talking about the direction of the movement of their particles, is transverse waves. Transverse waves have particles that vibrate up and down. And these you'll typically find with light waves, oscillating string, and seismic S waves. These waves, as I mentioned earlier, have crests and troughs. a distinct high point and a distinct low point. And that's what you see here in these two diagrams.